So for binary lists, the main objective here is that through each consecutive iteration, we will be looking at 1/2 of the previous iteration, right? So we'll slowly be getting to a smaller list of numbers that we'll look at to see for our target value. So with binary search, you need a left, a middle, and a right index, as shown here. And your left will always be the 0, the index of the first element, and your right will always be the index of your last element. So in this case, 9 is the index of our last element in our list. And middle, so middle is not predetermined, but so if whenever the left is smaller or equal to the right, which in this case it is true, the middle will be equal to the left plus the right divided by 2, but integer division. So in this case, 0 plus 9 divided by 2 is equal to 4.5, but because it's integers, it equals 4. So our middle becomes 4, right? And now what we do is we find the element at the index of our middle index. So that means the element at index 4, which is 40, and we compare that with our target. So in this case, because 66 is greater than 40, the element at index 4, our left index is going to change. Our left index is going to become a new number, and it will become middle plus 1. If we'll get into this in a later one, but if the target index would have been less than 40, the right would have changed, and right would have become middle minus 1. Or if the target would be equal to 40, right? If we were, let's say our target was 40, and 40 would equal 40, then our binary search would return the middle index because we've located that value, right? So, but for now, we didn't, and since 66 is greater than 40, our left becomes middle plus 1. So if we go to here, the left becomes middle plus 1, which is 5. The right becomes 9. And the middle, it's going to be something new, because remember, this only happens, we only get a middle if the left is less than or equal to the right. In this case it is, again, so the middle would be 5 plus 9 divided by 2, which is 7. And so now we look at it and we think, okay, so is 66 greater than the element at index 7? In this case it's not, because 66 is not greater than 66. Vice versa, is 66 less than the element at our index 7, which is not. So finally, the last possible comparison is, are they equal? Which they are. 66 equals element at index 7, which means our binary search would return 7, which returns the middle. And so, that means, this would return 7. Return 7, and that is, the binary search. But let's do another thing. 1 second. Okay. Let's say in this case, our target was equal to 69, right? Let's try that. So let's start from the beginning. Our left index is 0. Starts at 0. And then our right is 9, as always, because remember, the first and the last. Middle is not determined. But middle, if left is less than or equal to right, which it is, our middle becomes 0 plus 9 divided by 2, integer division, which is 4. So same thing, right? Because think about it. At this point, right, if we look back to this, the first one, right, our left is here and our right is here. So it's encompassing the whole list. But when we get to the next iteration, the left is now here and our right is here. So it's only encompassing this second half of the list, right? And that's essentially what we're doing.
Oh my God.
So let's go back here. If we look at, okay, is 69 is greater than the element at index 4, because 69 is greater than 40. So in this case, we would change the left value. We would get a new left value, a left index value, which means our left becomes 5 because the previous mid was 4, and 4 plus 1 is 5. And then our mid is Our mid is not yet determined, and our right stays the same because nothing happens to it. So this stays 9. And so our target was 69, just keep that in mind. So then again, our mid now becomes 5 plus 9 divided by 2, that's 7. So think, let's look at our index at 7, 66. 69 is still greater than 66, the element at index 7. So in this case, we get a new left index again. And in this case, so it was 7, that means left would be 7 plus 1, which is 8. And then our mid is not determined yet, and then our right is 9, hasn't changed. But notice, look at here now. Our left is at 8, which is left, and our right is right here at 9. Notice how now we're only encompassing this half, which is half of this initial half we had, right? We went from being concerned about these to now this smaller half of it, right? And so our middle becomes 8 plus 9 divided by 2, which is integer division. It is 8. Because 8 is less than 9. And then if we find the element at 8 this time, so the element at index 8 is 71. So this time we're not gonna add, our left is not gonna change, our right is gonna change, because now 69 is less than the element at our middle index. So in this case, the right would become middle minus 1. So we look at this, that means our right becomes middle minus 1, which is 8 minus 1, because our middle was 8, so 7. And then our left stays the same. And then the middle now, again, now we have to see, are we gonna get a middle? But in this case, notice, remember how we said that the left had to be less than or equal to the right? But now, the left is 8 while the right is 7, so this does not apply, which means we don't get a middle, right? We don't apply this, and instead our code just returns -1 instead of getting a middle value, which means, and that means -1, which means our element is not in the index, and it's true because 69 is not in this list, so we would return -1.